All right, we're going to be talking about solving linear systems using technology today. So we just talked about solving linear systems and doing it by the math using elimination or substitution, usually the elimination method. But there is a technological way to be able to do this. We can do that with what is called augmented matrices, or in singular, a matrix, which is a rectangular arrangement of numbers. The dimensions of a matrix with m rows and n columns are m by n, read m by n. That big X is a by. So the dimensions of a matrix A are 2 by 3. The numbers in the matrix are its elements. So there's matrix A. It's got 2 rows and 3 columns, so it's 2 by 3. And the element in the first row, third column, is 5, as they have highlighted there. A matrix derived from a system of linear equations, each written in standard form with the constant term on the right, and we'll talk about standard form later. But basically, it's got to be alphabetical order, and the thing in front of X has got to be positive. It doesn't have to be in this case, but it's an augmented matrix of the system. Augmented because there's an equal sign in there. It's not just a list of numbers, it's an equation. So you can see an example down below where we've got 5x, 3y, and 2z minus 1. X plus 2y plus 3z equals -1, and 3x minus 4y plus z equals 10. You can write that as an augmented matrix. You just drop all the letters. You just write all the coefficients down, including their signs. The equal signs becomes the 3 dots, and then the answers are over on the right side, the constants. So before you write an augmented matrix, make sure each question in the system is written in standard form. Basically, line up the x's, line up the y's, line up the z's, line up the constants. And you have to include zeros for any place where something is not included. So let's look at an example. We're going to write an augmented matrix for the system, then state the dimensions. So we have to get it in standard form. So we're going to rewrite a top equation with, I need a pen first. Negative 2x, take the sign with it. It's a positive y equals 1. You got x plus 3y equals 12. So as an augmented matrix, I'm going to have -2, 1, and then I have a 1. And then I've got 1, 3, and the answer side is 12. That's my augmented matrix. And it is a 2 rows by 3 columns. So if you need to solve a linear system with 2 variables, you're going to use a 2 by 3 matrix. Now let's look at example 2. So this is just bigger, okay? Now, if we look at this, we've got to rearrange some things, like z's over on the right side. So we're going to add 2z over here. So we get 3x minus 4y plus 2z equals 7. And the next one, I've got 9x, I've got 3y, but I don't have any z's, so I'm going to put 0 z's in there and then a 3 on the side. And then I've got 2x, -4y, -z, and then I got a 2. So my augmented matrix is going to be a little bigger. I've got 3, -4, 2, and then I've got my 7. I've got 9, 3, 0, and I got my 3, and I got 2, -4, -1, and then 2, and that's going to be a 3 by 4 matrix. That's what we're looking for. All right, here's some practice problems for you. Go ahead and push pause, give these a try, write the augmented matrix and state the dimensions, and unpause, and you can see me work the answers. Okay, here we go. All right, x's are lined up, y's are lined up, numbers are lined up, so all I got to do is make the matrix. So that's 1, -8, and -4, and then that's 5, 2, and a 9, and that's a 2 by 3. All right, we look at these. X's are lined up, y's are lined up, z's are not lined up. I got to move that z over. So I'm going to add z to both sides. I'm going to rewrite it just below. So I've got x plus y plus z equals 1. So I've rewritten that. All right, so I'm probably going to need a bigger matrix than that. Now, it should be the top one. The red one's the top one, so I'm going to make that my first list. So I'm going to make that a 1, a 1, and a 1, and then a 1. Then I'm going to put my 7, my 9, my -1, my -2, and my 6, my 4, my 8, and my 0. And that's a 3x4. And then let's see, X's are lined up, Y's are lined up, Z's are lined up. I'm missing a Z, so I'm going to add plus 0Z. And my numbers are lined up. So 9, -8, 3, 11, 1, -1, 2, 6, -1, let's see, 4, 0, 16. And that's a 3x4. Okay.